Okay, so we want to have a look at surds. Surds are obviously just the square roots. And what's the opposite of a square root? It's obviously to the power of 2, which is squares. So as we can see here, the square root of 4 is equal to 2. Where did the 2 come from? The 2 would have come from 2 squared, which is obviously 4, and then you take the square root of that. And that's going to be our main focus with trying to change things into entire surds or trying to simplify surds. So, for example, let's say we had 3 root 2. Okay, and if it says entire surds, that means we want it to be entirely a surd. So this root 2 is fine, but this 3 is not. What we want to do, we want to change this 3 here into an entire surd. So where did this 3 come from? Where did it come from? Well, the 3, just like here, it would have come from a root 9. Right? That 3 is a root 9. Then this root 2, you follow it down. That doesn't change. That stays as root 2. The reason why is because you want it as an entire surd. So you don't want to change the surds. You just want to change the numbers that are not surds or that are not in square root form. Now, from this rule, obviously, root A times root B can equal to root A times B. So we are allowed to multiply surds that are different. So you see this is a root 9 times root 2. That becomes root 9 times 2, which equals to root 18. Okay, let's try another example. Let's try 5 root, and let's try 6. Okay, so we want to write this as an entire surd again. See this root 6 here? We like that. That's already as a surd. However, this 5 here we don't like because it's not a surd. So we want to change this 5 into a surd. How? Well, we can do that by going where 5 came from. The 5 would have come from, obviously, square root of 25. If you want to remember, we've got 2 squared, that's 4. 3 squared, that's 9. 4 squared, that's 16. 5 squared, and so on. So if you want to work out where 5 came from, you can see you got to get rid of this square. So what's the opposite of square? That's square root, and what you do to one side, you got to do to the other. So 5 is actually equal to the square root of 25. 4 is actually equal to the square root of 16. 3 is actually equal to square root of 9. And that's the actual focus. So all we want is all these numbers. We're not interested in these numbers anymore. Cool? So square root of 25 times square root of 6. Okay? Then you can just plug that in exactly the same as what we did above here. So that's going to be square root of 6 times 25, which should give us 150. So square root of 150. All right, let's try one more. How about we try 11 root, and let's try 11. Okay, well, that root 11 we like. We don't want to change that. But this 11 here is the one that we're worried about. Where did 11 come from? It came from 121 because the square root of 121 would have given us 11 again. And then this root 11 stays the same. And voila, we've got 121 times 11, which is 1,331. Okay, now let's try how to simplify surds. So that's how you write them as entire surds. Let's learn simplifying surds now. Okay, to do simplifying surds, we're going to do the exact opposite of what we just did. They're already going to be in this form, or in this form, or in this form. And we want to get back into the actual original. So we want to get back to this, 3 root 2. The way to do that is to look for your perfect square. So to look for 2 squared, 3 squared, 4 squared, 5 squared, because then when we square root it, we've got a whole number again. So let me take an example. Let's go with root 12. Okay, the way you want to do it is think of the factors of 12. So factors of 12. You might go, okay, Sam, there's 6 and 2, there's 12 and 1, and there's 4 and 3. But this and this is not going to help us because the square root of 6 and the square root of 2 is not going to give us anything important. Likewise for 12 and 1. However, this one here can give us some vital information. It can give us the square root of 4 can simplify to a 2. And that's what we actually want with surds, okay? We want to simplify them. So root 12 can actually be written as root 4 times 3, which equals to root 4 times root 3, which equals to, and what's root 4 equal to? That should equal to 2, right? So then that's 2 times root 3, and we just simply write that as 2 root 3. Okay, let's try another one. How about if it was root 50? Well, you can go ahead and list all the factors, whereas the way I would do it is try to divide 50 by your perfect numbers, by perfect squares. So 50 divided by 4, 50 divided by 16, 50 divided by 9, I missed 9 there, but 9, and then 25, and so forth, until you get the smallest number you possibly can. When we did 50 divided by 25, that actually gives us 2. So we know that the composition of 50 would have been square root of 25 times 2, because of the factors. The factors are 25 and 2, right? So square root of 25 times 2, and the same thing as before, we can split them up, getting 5 root 2. Okay, hopefully that helps now.